Welcome to our class today. This is the first class, the first module under quantitative data management and analysis using SPSS course. So now we want just to move direct to understanding the program that we are going to use for doing what we call data analysis. This program is called SPSS. Now, if you look at it, it is designed like an Excel. It's a kind of an Excel. This is the program that we want to learn first during our first module. So now SPSS stands for Statistical Program for Social Sciences. That is now the acronym. The acronym SPSS stands for Statistical Program for Social Sciences. Now, it was recently renamed to be called PASW, simply means Predictive Analytic Software Statistics. So now we are using this SPSS to be able to perform quantitative data analysis. It supports what you call quantitative data analysis. Now, SPSS comes into the picture after data has already been collected from the field. Now, we can use different means of collecting data. Currently, we apply a lot of technology in collecting data, like in our institute, we do a lot of training in ODK, home care, and also even the Google Forms. All these are technology that we use for what we call Honor. We also have what we call Power BI. We use this as collecting tools by which we can support what we call data collection. So once data has already been collected, we now bring in the analysis component, and this is where SPSS comes into the picture. Now, SPSS is menu driven. It operates under what we call menu. It's not like a program, like the way we talk about R, Python, all those are what we call programs. Now, this is not a program, it's actually menu driven. So you come to file, you come to edit, you come to view, you come to data, you come to transform, you come to analyze, you come to graphs, and then you perform your operation. When you click that, you are going to be directed to, you choose now the appropriate procedure that you need to perform using what we call this SPSS. So now this is a user-friendly software, and it's also one of the most popular software since it is very easy. It's very easy, and especially for the beginners, it gives you a platform of beginning the data analysis journey. So that's why it's mostly used for what you call, even the university, for training people when they are introduced into what you call the statistical world data analysis. We use this very often. Now, in this program, we are able to perform different operations. One of it is generate report. We can be able to do what you call descriptive statistics, frequencies, and also perform what you call various descriptive using what you call our continuous variables. And also we can explore so that we understand better the nature of the variable that we already have. So there's what you call option for exploration. There we have options for exploration. We have options for comparing two variables that are categorical variables, the cross tabulation. We have that as an option here. We have QQ plots and etc. We have what you call compare means. We have general linear models. We have general linear model, mixed models, correlations, regressions, log linear, neural networks. All these are functions. We can also do what we call dimension reduction. All this can be performed by what you call SPSS. SPSS can also support what you call data visualization by simply doing the graph, coming to the graph menu, and then you can be able to perform all these operations, doing bar graph, three-dimensional bar graph, line graph, pie chart, high and low, box plot, population pyramid, scatter plot, and histogram. All this you can be able to support. And currently, actually, we are really encouraging situations whereby anytime that you want to give your report, you support your reports by the visual component of it, because that is what is being emphasized so much in data science. Okay, so good for that. So I want to bring in the concept of what is this kind of intercept. So SPSS has two windows. There is a window called variable view that we are in right now. And then there's another window where when we have already collected data from the respondent, we feed in the information the respondent has given us in this part called data view. So there's data and there's variable. So we start with variable, then we move data. So when I am at the variable, so I have to have this down here, I have a name, which means each variable must be named. That variable is called an observation. In a research, every observation requires a name. So you may realize that you have already designed your questionnaire, and these observations, and you have arranged them in a certain order, just the way we do. That when questionnaires we design, we arrange them using some particular order. Even if it is an evaluation, you will find that at least Questions testing sustainability needs to be brought together. Questions testing effectiveness needs to be brought together. Questions testing efficiency needs to be brought together. Questions testing on the impact of the program also need to be brought together. Question testing specific objectives needs to be brought together. Those are what we call the outcome measurement. So that is an arrangement that we normally adopt. If it is for the case of students, either you're doing your PhD or you're doing your postgraduate, then you'll realize that the first questions or the last questions will be demographic information. So if at all that is the kind of arrangement, why can't we use what you call perhaps a kind of abbreviation in feeding into the name? Name can take a whole number. Like for instance, the first question is gender. I can just put it like that, is gender. The next question is education. I can feed it, that is education. Okay. The second question might be marital status. Marital status, it is a variable on its own. Variable on its own. Okay. It has refused marital status. So it's feeding on its own. But now we need to know which names do SPSS recognize. The name SPSS will recognize must start with alphanumeric. It must be an alphabet. So if at all we introduce something like 1, and then I write gender, SPSS will automatically reject it since 1 is a number. So let me try this. Look at what SPSS has told me. Variable name contains an illegal first character. So SPSS is so accurate to an extent that it even direct me where the error is. The error is the first name. So the first name must obey the rule that it's alphanumeric. So if I put it as alphanumeric, it will be accepted. Next order of naming is that the name must not have any space in between. Like for instance, I'm just talking about gender of the respondent. Let me look at this, gender of the respondent. So I write here gender, and then I put in space of the respondent, That one is not going to be accepted since names should not have what you call in spacing. Variable name contains an illegal character. It's another case that it should not have a space in between. Neither should we use symbols or notations that are commonly used like NB, signs like a comma, question mark, and etc. Those ones we are not supposed to employ here, but we can use them in between once at least alphanumeric has already taken place. But now the standard approach by which now I'm encouraging is a situation whereby you know that your first question are demographic information. Why can't you use the name D? We just simply come here and then write D. We write D. So when we just write D, once we write D, then because it is the first demographic information, so we put underscore 1. So it simply means that is the first demographic information characteristic of the respondent that I'm trying to investigate. And these characteristics are not just done haphazardly. They are based on the kind of information you are looking for. For instance, you are writing a questionnaire on nutritional study. Remember, aspects like age, aspect like weight, aspect like height is very important in a nutritional study because definitely we'll be calculating things like BMI and etc. So now, based on the kind of particular study that you're conducting, this characteristic of the respondent will at least characteristic of interest. They are the ones that we say. If marital status is not a factor to be analyzed, ignore it. If education perhaps may not affect what you call variability on the subject that I'm studying, then I don't need it. But if I feel that education is important in regard to the kind of information I'm going to collect from the respondent, then I will bring it there. So if at all height is a factor, I bring height. If education is a factor, I bring education. If gender, I feel that perhaps investigating whether there's what you call significant difference between gender is a factor in my study, then I bring what you call gender. So that is the order of bringing in this information. And remember, this particular information, you will be faced with instances where sometimes you may be running a model like multiple linear regression while you are introducing what you call this particular gender as in the model. Yeah, you're dummy. Once immediately we are going to introduce what you call the standards by which you can be able to imply, to incorporate such that a dummy variable can be included with what you call our parametric, the models that we are running. So now education. So that education will be D_2. That is marital status is D_3. Then another D_4 may be simply telephone number. We are interested in indicating what you call telephone, indicate your telephone number or national ID. telephone number. Let's just use what we call telephone number or even national ID. That is what we want to collect from the respondent. If that, and remember, we must also be very careful because there is what we call ethics that prohibits us to be able to use anything that may be able to identify that respondent that's going to give us what we call the answer, like something like a name. We try to avoid the issue of their names being here. Part of confidentiality, going against confidentiality and secrecy, is that now our respondent must remain anonymous as much as possible so that at least they can never be traced or victimized based on the information that they've already been given. So that's why we no need to identify this kind of identification. We try to avoid them as much as possible. And since I'm doing illustration, there's nothing wrong by me introducing that here. So the first one is perhaps the gender of the respondent, and then we talk about highest level of education, highest level of education, and then I talk about marital status as the second question. Marital status as the second question. Then D_5, I will talk about _5. I talk about perhaps the weight of the respondent, and then now D_6, assuming that I'm doing a nutritional study, D_6, I will put to be the height of the respondent, So that's the information. And then now I come to my main variable. The first variable I'm trying to investigate is how the program, perhaps whether the program was sustainable. So I've put in various questions on sustainability. And my first question is, I bring it S_1. Then I talk about S_2, S_3, S_3. That simply means the question on sustainability, this is S_3. So now, assuming that these are 10 questions, that is exactly what I want to do. So that variable is complete. I go to the next variable of effectiveness. So it is E_1. Then I have 10 questions on effectiveness. Then after effectiveness, I go to the next question on impact. I may even write impact. There's nothing wrong by that. And then I bring in _1. Then I will have perhaps 20 questions on the impact. Then immediately after that, I go to the next until all my questions in the questionnaire has been exhausted. Even if at all I have a parameter like even performance, I may be even indicate performance. You can even write performance question 1, question 2, question 3, question 4 until the last question. So that is how at least I'm manually supposed to enter variables in the variable view. Apart from that, I need to go to this part column called type, variable type. So now the variable type have up there, you will click that and then you find various ways by which you can present a variable types. So we have 8 types. We have numeric, we have comma, we have dot, we have scientific quotation, we have date, we have dollar, we have custom currency, we have string, and then restricted numeric integer with the leading zero. Now, the most commonly used in the SPSS are 3. Definitely, any variable that you have keyed in under the variable view is going to be a default functions of numeric. But then we also have what you call date, which can be used. For instance, one of the questions here I was testing is the date of the respondent. So I simply need to bring in the date and come and click and tell that the variable type here is date. Immediately, if you don't key in proper variable type, then definitely you will not be able to do your data analysis. So it is very, very important that you key in this very well. Now look at the string. Any other variable that I'm keying in, which is not a numeric, then like for instance, the telephone number, definitely the telephone number is a non-numeric. So that telephone number is going to be a string variable. That telephone number is going to be what? A string variable. That telephone number is going to be a string variable. And therefore, I have to tell SPSS very well that this is a string, okay? In order for me to perform any operation on it. Now look at, there's a question here under D. Let's say this height indicates your telephone number. So I need to come here and then I indicate this as string so that I will be able to insert my telephone number, okay? So I've already indicated like that. Then now there's width here and then there's decimal. So width simply reflect the number of characters in the name. For instance, the name here has how many characters? This one has 3 characters. So this is, the default is 8. So it's still within that range. So if at all the name here was perhaps a name like Peter Nyachome, a name like Peter Nyachome, let me write Peter Nyachome, a name like Peter Nyachome, then you will find that the name like Peter Nyachome, when you now key in, let me just indicate a name here. Let me just write a name. Okay, indicate your name. So that if that the variable is to indicate a name, when I go into the data view, I want to insert my name, then you will find that my name has more characters than 8. So in that case, you come and adjust this so that you can be able to increase this before. It can go up to 25 to be able to fit my name, because if I leave it at 8, definitely you will find that when I go to write my name, it will not be able to succeed. Now look at that name. All right, let me try. I try to increasing this line so big, and then I want to write the name Peter Nyachome as the variable here. You'll find that that is Peter, and then I come and write here Nyachome. It is actually, is it accepting? It's not actually accepting. So we simply need now to investigate why is it not accepting. So you will find that if you increase the length, definitely it will now just accept. And then we don't need to indicate here to be numeric. That name should be a string. So we come here and indicate it is a string variable, so that now when I go back, just write my name, it will fix very, very well. It will just simply fix very, very well. So now you can see it has appeared, it has remained. Now in this case, we were putting it at left. So when you come here, you find that now that's how to do what you call clearly identify the data type. Even if at all this data you have brought from what you call SPSS, Excel, ensure that the data type is clearly indicated. The first question, the first variable normally is an identification. It may be kind of a serial number or even a division number of the respondent. What you are going to use to identify your respondent, it can be that. So you have to ensure that that kind of identification is not given to be a numeric, but it is a string variable, so that we accept it the way it is. It can be 101, that is the first respondent, 102 is the second respondent, in that particular order. Okay, so now, having known that, you also need to fill in all these questions, what they mean. Now you bring in your questionnaire the way they were, questions the way they were in your questionnaire, and come and plug them here under what you call label. Come and give them full description, such that anyone will be able to know E_1, what does it mean? Impact_1, what does it mean? S_3, what does it mean? So there we can only get them to this component called label. In case you go to for an interview, because mostly currently for those who are attending interview, you'll realize that the interviews currently are being divided into two. There's a practical session that you attend first, and then you go for what you call the oral. So you find that when you go to that practical session, you will be given a data. Mostly they prefer giving data like in SPSS like this. Now, if you cannot be able to understand this abbreviation, please come to this section called label, so that you can be able to specifically understand the kind of variable that these people are doing, what they were describing. So that is exactly how the approach we need to give it to this. So we must be able to fill this completely. Okay. Then now, once you have already done that, you go now to collect data from the field and bring your first questionnaire and begin to fill it. Now you come to the question, they call values. All categorical variables must be coded. And this is now the column where we are coding values. So you come and click OK there under values, and the value 1, you want to say this male. And then 0, you want to say that is female. In this particular case, I'm treating gender as a dichotomous variable, and that makes me to code it in terms of 0 and 1, where 0 in this case is the category of not of interest, significant interest, and then 1 is the category of interest. What simply means this now the concept of what I'm calling about dummy coding of variables. So now, when I do a dummy code like that, it will be sufficient for me to use gender even in linear regression equations as a component whereby you are adding that particular variable. Since I already obeyed what you call that dummy in the coding system. This is only done when it's a dichotomous variable. Variables like which are binary in nature. Like for instance, you go to test for COVID-19. The doctors, you are waiting for the result. Likely that the result the doctor is going to give you either can only take 2 forms. It can either be yes, you are positive, or it's negative, you are not positive. Okay, it's negative, or so answers like positive, negative, that is a dichotomous. Answers like yes or no, like a survey we conducted, and then we are trying to investigate ability for our school girls and school boys delaying sex before they get married. Now, what we were simply measuring in that particular study was the sexual debut. ability of delaying sex before you get married. Then we tell them the question, are you able to delay until you get married? Then the options were yes or no. So you find that each and every student is going to choose yes or choose no. Then after a person has already chosen yes, so remember in that coding, I will say yes is 1, I code it 1, and no, I code it to be 0, because no is not a variable, a category of interest. The category of interest is yes, ability to delay sex until I'm married. Such that once I've already, as students already told me yes, then I go back to look at what could have been the factors attributing to yes. Since now I want to look at what are these factors that are influencing ability of students delaying sex until they get married, such that I can be able to write a paper and convince that at least these factors, if taken care of, then definitely we are going to have just a very good moral society outside there, where people know that engaging in sex and getting pregnant before you get married is not something that is good. Okay, so that's the kind of paper that I was interested in. I mean, that's a particular case where I will definitely run what you call binary logistic regression or binary probability regressions model to fit in the particular study that I was doing. Okay, so in medical sciences, we normally use this particular kind of results that are binary in nature, dichotomous. Good. So when I come to highest level of education, I will put options. The first option is 1, I give it to be the primary level of study. Then number 2, I bring it is now the secondary level of study. Then now number 3, I bring it is the college level. Then number 4, I bring it is the undergraduate. I bring it is the undergraduate. I bring it at undergraduate level. And then 5, I will put the options of postgraduate. So now every respondent, when I go to, I will be collecting data with regard to the education level. Why is it this important? This is important because I want to know whether with education, there's a likelihood that with a higher education, a person's level of giving me information increases. It's more advanced. This is a person who at least understands things well. So, and that's why now I'm trying to look at, is there an element of quality that the kind of information I received it from the right people? Is it that perhaps I received the information in the wrong people without any knowledge? So now I can be able to test your quality of the information you collected by this education level. And this education level is in rank. Remember what I've put here is rank. The lowest is primary and then the highest is 5. So this kind of ranked responses are what we are going to describe later as ordinal measurements. This is a ranked response. You can simply know the lowest and then the highest level of measurement. Now we move to the next level is marital status. Marital status in this regard, I will put 1 as single people, the people who are not yet married. And then I will put the second one as married people, married. And then I will put the third one as widowed, the people who are widowed. And then I will also put another option here for people who are temporarily separated. So I come here and then I say people and then I say separated. So there can be a separation with a willingness of coming back, and there can also be a separation that definitely leads to what you call divorce. So I will also widowed. And then finally, I talk about widowed and not widowed. Widowed, I've already put it. The next one is divorce. The next one is divorce. So divorce is not coming back. You don't divorce and then you come back. You divorce and it becomes permanent. Separated, at least there's an option of coming back. So that is now the option that I've already provided. Now, telephone number, provide your telephone number. This is not supposed to be given what you call a category. Yeah, that is not going to be a string variable. Now, weight is also, I'm not going to provide weight with what you call category. So this weight is going to be given as a continuous variable. So a person will only tell us the weight 65.5, something like that. Height equally is going not to be given a category. So we must be very much interested in now which variables do I put in the category and which variables will remain without that. Then I come to the missing. This missing column is very important because now you will not, sometimes you may not get all 100% responses from what you call your respondent. Some may not opt not to fill in some questions. Perhaps those questions are embarrassing. So if at all you have given an embarrassing question to the respondent, definitely they will not fill that. Or sometimes those questions are secrets. Like for instance, you are asking, going to a family and then trying to ask, doing an interview and trying to ask, there is a father and there is a mother, and trying to ask, how much do you earn? Perhaps the father had never released how much he earns to the wife, since now releasing that information bring in a lot of demands from the wife. That you mean you just earn a lot of money like that, and here you are just giving me a pocket money of 220,000? Now that is not possible. So perhaps now, if they don't know how much you earn, anything you give, they will check with appreciation and then say, thank you so much. God bless you for this gift that you have given me. So some people like that to manage their wives very well. They don't want them to know how much they earn, perhaps until the day the wife, and the wives are very interesting that they know, if you go with the pay slips, they will have to know because they do their own due diligence in your records. So, so you will find that at least if you know that you are keeping in a secret, you should not now attempt going with what you call your payslip home. So now, if that information may not be, the respondent will not be willing to release it before you in the presence of the wife, then definitely you will not get it. So that question will be left blank. Those are now attempting to explain to you some of the reasons why questions are missing. It may also be that that question is not applicable to that particular respondent. Like for instance, you ask, are you married? Then the answer is yes or no. If no, skip question 3, because that particular question belongs to the married people. So you only go to the question that belongs to you. So it may be not applicable, may result for a question not being missing. Alternatively, the question intentionally skipped, not answered. Those are now the reasons why particular questions may be left missing. And then use specific denotations for missing values. 98, not applicable. 99, the respondent has forgotten the question. 97, the question perhaps the respondent has not failed that particular question. He's left it blank. So we are supposed to specify which kind of missing is it. Is it missing as a result of not applicable? Is it missing as a result of the question is embarrassing and the respondent has refused to give an answer, or he has forgotten it? Is it missing as a result of forgetting? Is it missing as a result of embarrassing question, or is it missing as a result of not applicable to that respondent? Then the issue of column and alignment is just the way you want the arrangement of our result to be. Do you meant it to left? Do you meant it to the right or center? This is now the issue here and alignment. So we can decide perhaps now to put perhaps everything here center, so that you are going to find that now the results that we are going to populate in our all of them will definitely be center. They will all be center. So now next is measurement. So what is this under measurement? Each variable must reflect how that variable is being measured. Okay, be it that it was just so we have SPSS providers with only 3 options. One is scale. So under scale, we have 2 types of scale. We have interval scale, and then we have ratio scale. Now the interval scale is now where like we are trying to measure the temperature of a person. Remember, temperature is measured in degree Fahrenheit or Celsius. Now 0 degrees Celsius has a meaning. Now that is like an example where we talk about the interval scale. But when we talk about the ratio scale, then definitely instances where 0 between the distance between points have no meaning at all. Like for instance, 0 amount of money in your bank account. It simply means lack of money. Then 0 kilometers traveled. It simply means not travel at all, not made. So in such instances, that's an example of a ratio scale. Okay. Then under all scales, we also have 2 subcategories of classifying them. It can be classified as continuous variable. A continuous variable are all measurables. Measurable. When you measure temperature, you measure height, all those are continuous variables. Okay. But then all countables are called discrete variables. You can count, like for instance, the number of children you have. You can count the amount of money in your bank account or the amount of money in your pocket. You can count one by one. That is a countable. So all countables are called discrete variables. They normally check the form of whole number. How many cows do you have? Camels, especially doing a survey in those parts of Somalia. Talk about camels of households, trying to talk about the average camels each household have. What is the number of camels you have? So I have 2. I have, even if at all a calf, a young one, you are going to say, I have 4 children. Even if today you have given birth to a 1-day-old, you will count that child as a whole number. So you'll talk about I have 4 children. Not I have 2 and I have because another one has just been born yesterday. So we don't talk like that. So all countables, they check all numbers. And in that position, we don't require decimal points for countables. So this decimal points also needs to be changed based on the kind of thing that you already have. So after that, we could come to categorical variables. So categorical variables are divided into 3, but SPSS only give us 2 options. One is ordinal measurement, which are ranked scale, like Likert scale. In a scale of 1 to 10, tell us the performance of your president since he came into power. That is a Likert scale. In a scale of 1 to 5, are you satisfied with the training provider? 1 means you are unsatisfied, and 5 means you are highly satisfied with the training provider, the methodology by which the training was delivered. So in that perspective, we are going to give a mark, a number, based on our level of agreement and level of satisfaction with the particular service that we are receiving from our service provider. So in such a case, we talk about these are ordinal measurement. And we have specific statistics to support ordinal. And that's why we talk about ordinal logistic or probit models are very much appropriate wherever our subject of measurement is ordinal. When subject, like for instance, you are looking at the performance of employees in an organization. So now the performance, you collected the performance parameter in a kind of a Likert scale. Therefore, you will be expected now to run what we call ordinal. You're just trying to look at the parameters, the predictors that are very much influential in adding more value to the performance. What are they? So it is a probability kind of model. These are what we're calling the probability model. We're trying to predict that this particular variable can be able to influence performance to this level. Okay, but remember, performance of an employee, we can be able to, you design a scale. If you design a scale, you can be able to consider it as a ranked response. Okay, then next, we talk about nominal variables. Now, these are where we are simply dealing with descriptions. We are simply describing a variable and we are putting a number which does not have any relationship at all with the kind of variables that you are talking about. Now, for instance, let's look at a variable marital status. We have here provided marital status into 5 categories. Single. One does not have any relationship with being a single or not. Singleness, they doesn't have any relationship. 2, married, which now this simply means the number that we have given to this particular items that we are describing here, they don't have any relationship at all. And there's no spatial order. I can interchange, like for instance, I start with 1 is divorced, 2 is married, 3, it does not have any other order. And that's why we normally say, whenever you're dealing with categorical variables of this nature, don't go ahead telling us about the mean and standard deviation of those variables. It is better just present the frequencies of that variable and support them with even things like pie charts so that you can be able to see the distribution of the respondent with regard to their marital status. But don't let us not talk about standard deviation. Let us not talk about mean. Yes, mean are only permissible when we are talking about the scale variables. When we talk about continuous and discrete variable, that's where at least now the mean values make sense. Okay, that's good. So to that extent, we can say now that's exactly what, now I come to the data view. So when I come to the data view, the first question was gender, male. Me, I'm a male, so I say 1. The next question is highest level of education. Now 5, postgraduate, 5. Now number 3, marital status, 2, married. Then the next question is indicate your telephone number, question number 4. Now telephone number is now a very distinct. So I now put my telephone number. I simply come write 0721 57 3590. Now look at what is happening. I was writing my telephone number and I could only manage how many digits? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Only 8. I'm now trying to write others, it has repeated. So what has gone wrong? It is because the weight that I provided was 8. I need to increase that weight. So I come down here and instead of 8, I now put it something like 13. Then I go back and add my values. I go back and add. So 0721 57 35 90. Now it has already accommodated that. Then I go to the question number 5. Question number 5 is weight. So I come and write my weight. I come and write my weight. My weight, I don't weigh so much. I weigh just around 70. Okay. Then I simply come and write the next one is height. Okay, height. So height, I will say 1.68. And then now I come back to these particular questions that were now specific to the variable that I was trying to measure in that case, and even the place where I was writing my name. So that first question I put aside and I mark it number 1, or I give it the identification of that particular questionnaire. I put it somewhere there for at least later I can be able to come and check. I pick in question number 2 and I key it like that. Question number 3, I key it like that. Okay. So now sometimes you have 600 questionnaires. One person may not be able to be the one who's failing. So now you distribute 100 questions each, and then you give them the number, the serial numbers, how they need to note. Like if at all you divide into 10, 10, the first one is 1 up to 10. The next one you tell him you start with 11 up to 20, and then the next one you start with this. Then you key in each and every person is going to key questions, and then you are a supervisor who is supposed to counter check the accuracy level of your clerks. Then after that, you just merge those files to create just one big file, something like that. So now, what I want us to tell you that this is the manual way of doing it. And since that manual way of doing it currently is a little bit rare, so we want to learn the second option. The second option is bringing the file that's already been in another interface. It can be in Excel, and you bring it into what you call SPSS. Now, that is now the second option that we want to go to. So how do we do that? So in that case, you come to this menu called File. Then you come to this Open. Then you come to Data. Then you click that data. So once the data is opened, you need now to direct SPSS. Where is that my file? So like in my case, the file is in desktop. So I come and bring in desktop. So in desktop, I come to this particular file. So under that, okay, I will be able to now to identify the various files that are here. But then the most important thing is in which format is that my file? So here, the format file type is SPSS. So I need to bring it into Excel. So I bring it into the Excel. So when I bring it in Excel, I will now come and transfer the data that I'm interested in. So in that case, that data has failed because that data has an error. So I will bring in now a data that is already in SPSS. Let me now bring in the SPSS format. So I bring in the SPSS format. I can be able to bring it in there. So I come and click it, and then I say open. Particular data is I bring in that particular data. So it's already brought for me the data. I can be able to share with you. So this is the data that I've already brought from what you call it is in another file that I was not working with, but this is an SPSS. But even if I tell it was in Excel, I just that is the mode of transferring any data that is in Excel or etc. or something like that. Then what do I need to do here? Now, what I need to do here is that I've already brought in. So immediately you have already done this. The next thing that you need to do is begin what we call as data cleanup. Data cleanup is very important. And especially if you go by the words of Abraham Lincoln, he once said that when you give me perhaps 4 hours to cut down a tree, I'll rather take time, like even 6 hours, making the axe that I will use to cut the tree. That is exactly what normally happens in data analysis. We spend a lot of time in data cleanup, but the analysis itself is easy because a matter of manual operations, and then within a short time, I've generated reports and I do what you call interpretation. The analysis itself only requires me to apply my knowledge in statistics. It doesn't require so much. Just the knowledge in statistics, that is enough. But then to make my data be suitable for analysis, that is now the hard thing. The reason why it is hard is because it's hardly something that is being taught outside there. Any conference that you go and attend for that analysis, you'll find the person doing what you call moderation or facilitation will be rushing very fast to the analysis itself and ignoring the fundamentals. And it makes now the so-called analysis becomes a little bit more complex because you have not been guided properly on what are these key factors that influence even how analysis is supposed to take place, and what are the powers do analysts have? Because remember, the analysts stand with some powers that the kind of information you want to present there, you are the one who know, and that's where we normally have the power of transformation. We can be able to transform that particular data I collected the way I want, based on the kind of information I want to pass across. Okay, so you may find that you are doing analysis for the same subject, but then the result and how you are doing it, you are two different people, and you don't need just to follow one another, copying. There's nothing like copying. So sometimes I get scared when I go to what you call these libraries around here. And then I find that all the students who collected their thesis in using Likert scale have ended up with a multiple linear regression. How? How did they manage everyone is ending up with that particular model? Well, that particular model is almost 1% or 2% chance that your data will meet all the conditions, the preconditions for running that particular model. How is it that everyone ended up with that particular model of multiple linear regression? In a case where multiple linear regression has 1% chance of being accepted. Even if at all you end up doing your transformation, you will end up doing transformation, and your transformation still fails that your data set has failed the normality test and all these other tests that are required before you can be able to run that particular model. Every model has a precondition. Have you met the necessary minimum condition for you to run that particular model? Now, or it is a matter of guesswork, or it's a matter of copying another person's work and then trying to make it to be yours so that you can graduate. That is how we have having very PhD holders who cannot even explain what ANOVA is. And he did a quantitative study. It's even better those who did qualitative studies be in that position. A person who did a quantitative study cannot even explain what R squared means. They don't know completely. Since at all, they were never put into this particular kind of training. Remember, even in the university, you'll hardly go to any university and then you are taken through a process like this. Very few. Expect the students who are doing what you call applied statistics. They are the ones that are being exposed to this particular kind of training. The rest is a matter of the theory, and then you're being manufactured so that you go out and we bring another group of people so that they can be able to pay school fees. Yeah, you take statistics all over. I meet different students from China. I train them, coach them here. They tell me what is happening there. At least I am very proud. In China, the universities, the lecturers are very, very thorough. They even request you to produce this particular output. Majority of the universities, the lecturer is not interested in even asking your output so that he can do it practically, whether you guessed your data or not. You just rely on what you call the report that you have generated. But did you do the necessary steps that are required before that analysis is done? Now look at what I've already presented here. This particular data that we already have here cannot be analyzed until we take it through what you call data cleanup process. So I want to take you through what you call the minimum basics of data cleanup, and then I shall take you through the process of what you call doing data cleanup. When we want to perform data cleanup, what are the axioms? What are the basic? What are the fundamentals? The data cleanup, the first thing is that key variables in the study must be examined and corrected if at all there is any error concerning our key variables. What are these key variables? These are the observations. They are the observations that the unit observation in my study, the unit observation. What did I observe in the field? I was observing the age level of the respondent. That age, is it captured well? I go to each variable, like for instance, the first one is sex. The next one is age, marital status. These are now observations. I need to understand what are they. Since now these denotations up here was simply reflecting how the variable was named. What is it? I need to go, even sometimes I will be doing what you call reference back to the variable B, so that when I come to end level, I simply got highest level of education. That is how it was noted. And then I've already told about that. So that's the first step of being, just to understand that all my variables of interest, the key variables of interest have been captured well. Number two, ensure that all your data customers variable are given a code of 0 and 1. That is the second step in the data cleanup process. So if at all, instead of sex, which is a gender, male and female, I coded as 1 male, 2 female. Then it is this process of doing data cleanup, I need to change that coding system. So that now, since this is a binary response, then I need to identify which is the variable of my main interest. So I put it that. That is now the second step that I need to go. All dichotomous variables must be given what you call a dummy coding system. Then properly fixed labels. I go back to variable view, and then I under label. Here is identification. Next is sex, age, marital status, highest level of education. Weight, you must come here and write weight of the respondent. There is nothing under label which will remain frank. Where is that? Height of the respondent. height of the respondent. So I complete. So I've already done that. So there will be nothing left unfilled under this level. All of them must be filled one by one. And this is a matter of transfer the questions the way they were in your questionnaire back to this particular point field. Equally, all categorical variables must be coded properly. Like now look at 01, which means this study is so much interested about what is happening with the men as opposed to women. That's why women we are giving them to 0. That is a category of less interest. Age, okay? So this is now coding. We are coding, giving numbers, categorical variables, okay? Then I come to what? I come to measurement. Like now, ID, that is a string, identification number of the variable. Now look at the way variables have been identified. Why? The first one is 83, the next one is 294. So we can use any mechanism of identifying those particular variables. What we are simply doing is trying to make sure that my data set remains anonymous, because that is one of the policies that we are trying to obey. Okay, then I do next is, I've already done that. So next one that I also need to do is check for what you call the duplicate values. But before that, I want to take you through the practical approach of doing what you call data cleanup. We normally start with initial data checking. So the initial data checking, I'm expected to go to the menu called view, like this. I come to view. After view, I come to value labels. Then I click it. Then definitely I can be able now to see all my categorical variables, how they were keyed in, and I can be able now to question myself, why are this missed? Why this is not failed? So that is already a pointer that you read particular questions and responses. The one missing simply tells you that that particular question could have not been given the answer. Now that is how I can have a clear picture of exactly what is happening. Now look at sets. All questions, if I never fail, then it will have a space. So if it has a space, I need to know why was that is a space? Why was it not filled? Does it mean that the question was not applicable? So it comes down, it boils down to the kind of reason why that question was missing. Okay, then you can simply perform the same operation that I've gone through view through this icon here. So you can click one, it goes back to the original numeric function. You click here, it goes back to how you can be able to do our initial checking. So that's exactly how we need to do initial checking of the data. Now, after that, we need to do what we call check for duplicate entries. Now, there are some cases where you find that a person's age has been repeated, 35. So we need to investigate. Does it repeated that exactly it is correct, or it is an issue of an error? So checking for duplicate cases, we need to come to this data and then go to identify duplicate. Then click there, okay. Then at least now bring in that data that we expect as duplicate under, for instance, age, under this defined by match by cases. After that, we need now, it's indicated primary last, first, so that's okay. We are going to create that primary, the primary last variable. And then what will happen is that the original values, the duplicate cases will be coded with 0, and then the primary last, the values without duplicates, will be given a code of 1. So in that perspective, I will come here and then say okay. And once I've already done okay, like that, I'm waiting for what you call the result to appear. I want to share with you the result that I've already generated, and then I go and confirm. So now, this particular case, I don't have any missing cases. Under age, there's no value that was missing. Duplicate cases. Okay, primary case. We find this primary case is 1. Now, let me take you to the original to the new value. Let me come to the last primary last. Look at the primary last values. Okay, this is the that is 0. I say the 0 simply in this particular case, 0 are duplicates. So I need to know how many duplicates do I have in this particular study. Now look at this. These are 1, 0, 0 is duplicate in this my study. Now the original values without duplicates are going to be also given. So all duplicate will be moved to 0. So what is the significance of this? Now I will go back to my original questionnaire and how I was able to identify them, so that I try to cross-check whether these particular duplicates were as a result of there's no error in them. Yeah. So I now must go to counter check. The ones reflecting that they are duplicate. What's the rationale? Is it true that they are duplicate? That's what I want to go and investigate. So once I've already investigated that, I may realize that perhaps the original questionnaire, the person wrote 53, but the analyst indicated 35. And then I can be able now to rectify that particular question with the correct value. So that's the essence of doing what you call this duplicate column, creating this duplicate column. Now, apart from that, I need now to go and I want to identify all the cases where my data was missing. So I want now to go to the operation of how to handle what you call missing values. So the missing values, I need to go to what you call transform. Transform, you click transform. And then you come and say replace missing values. And now the missing value that I want to replace here is the weight variable. So I come here, the weight of the respondent. It had some missing values. So what is the essence here? This weight that I brought here was simply coded to be weight, but then I want to create another weight 1. So I will say this weight 1. So I will say weight 2. Then I change here. So I'm going to have a new variable called weight 2. And because this weight is a continuous variable, I will replace it with mean series. I come here and click. These are ways to replace mean of nearby points. Median of nearby points is supposed to be used to replace categorical responses. And then we also have what we call linear interpolation. All these are ways by which you can be able to replace the missing value. So in our case, we come to mean of nearby points, since I'm dealing with what you call a continuous scale variable. Then I come and indicate here, okay. Then you say, okay. So now what has happened there is that I've simply replaced all the values that were missing. If you come to perhaps weight here, you'll find that it had several variables that were missing. They were not filled. Like now respondent number 249 has not failed. This one also has not failed. Score 2 is going to have all the values failed properly. Now look at this. This one, everything is failed. There's nothing nearby points. So I've done quite a number of operations. So next now is for subsequent analysis under weight, I will use this one that already been cleaned, where there's nothing that is now missing. And for instance, in this particular case, I just want to use this weight so that I identify whether this weight variable, they are outliers, extreme values. So I come here to analyze, and then I come here to descriptive, and then I come here to explore. I came there to explore. So under explore, I will bring in that particular variable called weight underscore 2. I bring it under dependent list. If you have to test for outlier for several variables, you bring all of them at a go. There's no problem for that. But then you come to this column called plots, and you click in histogram, and also click in normality plot with the test. Why histogram? Histogram can be used to identify extreme values. We also use histogram to be able to check the distribution of that particular variable. And remember, the assumptions here is the distribution is expected to originate from a population with a normal distribution. In that case, we are able to be supporting what we call inferential statistics. We can use that particular sample to make conclusion that the entire population can be able to behave that way. That is what we are calling as inferential statistics. Taking a sample, and after analyzing the sample, you can make a deduction that this is exactly what is expected from the entire population. And the reason why you have done that is because during the time then when you are conducting sample, each and every person that was included in the sample, we used what you call standard way of doing it. And we adopted the random sampling methodology. So every respondent was given equal chance of being picked to be included in the survey. That is what now we can use such particular kind of sample, conduct analysis, and then do generalization out from that. Otherwise, If that methodology was not used for collecting the data, then you are not supposed to do the inferential statistics out from the samples that you have already used. Unless now you talk about you are going to do a qualitative study where the component of inferential does not came into qualitative studies. Okay, so now I come and click OK. Under this operation, I will be testing two assumptions that are very important for performing my statistic. One is the concept of normality. Does my sample originate from a population with a normal distribution? That's the first question that I want to answer using this operation. The next, do we have outliers, which are extreme values? Then I come and say, okay, then I come now and I take you through what you call checking for the result that has been generated out from the operations that I've already performed. Let's wait for it down here. We are going to look at a number of, it's my responsibility to begin interpreting them. So exactly you can be able to see them. This is the first table, the descriptive statistic table. Now this descriptive statistic table, I need to go to the column written skewness. And then the statistic value under skewness divide with the standard error. If you get a value of plus or minus 1.96, then you conclude that your data set originates from a population with a normal distribution. That is the essence of introducing skewed value and kurtosis. Kurtosis just simply refer to the pickedness, and simply the rules remains the same since we are working at 95% confidence. Therefore, our what you call the Z value is 1.96 plus or minus is allowed for us to deduce that the data set has originated from a population with a normal distribution. Can somebody do for me this simple mathematics? Can you get this 1.051 divided by 0.148 and then give me what is the result for that? You can do that particular kind of operations, and then you unmute. You can unmute. Once you have already done that particular operations, you unmute and then you tell us what results have you got. What results have you got? Hello? Yes, Daniel. What is the result?
I'm here to check.
You are here to, yes?
1.0. 1.0.
You have got the result is 1.0. What is the result? 1.0. What is the results have you got, please? Before I go and interpret the other one.
Leon, I got 0.71. 0.71.
0.71. Now, yes. 0.71 is within the limits that we were looking for. So 0.71 is within the limits that we are looking for, since we were looking for a value of plus or minus 1.96. Anything that's beyond that simply signifies that my data set may not originate after all from a population with a normal distribution. So in this case, there is 1.052 divided by, I have 0.148. The result, I'm finding that your answer and mine are quite different. Can you divide this value well? 1.052 divided by 0.148. What is the result?
Hello.
Yes?
Yes, I'm having 0.0071.
I think there is an error that you guys are doing. Because if you take 1 point.
Hello, Peter.
Yes?
Yeah, I'm getting 7.108.
That is the correct one. Actually, that's what I'm getting here. It is 0.148. So it is 7.108. It simply means that this our data set is far away from having a normal distribution. But then you need to confirm that in the table below here. The table below here is telling us that what we are finding here is out from a sample of 271, the p-value is 0.00. Now, this p-value, when you get it's having less than 0.05, simply it signifies that the data set does not originate from a population with a normal distribution. This can be counter-confirmed by the histogram, because we'll expect the histogram to be skewed. Now look at the histogram. The histogram is leaning towards one side. This is an example of skewness. But even beside this skewness, there is an element of an outlier here in the histogram. This value here is far away from others. And that is how to be able to identify, use histogram to identify outlier. So using histogram, you can be able to do so many things. And even if I insert the curve of normal distribution, you'll see that that curve of normal distribution is far much away. I'm inserting that curve. I've already inserted that curve. Let me share with you so that you can be able to look at the curve I've already inserted. No, this is not normal distribution. The normal distribution, we expect the almost 3/4 of this particular histogram is covered very, very well. This is kneeling towards one side. Is it kneeling to the left or to the right? Which kind of skewness is this? Can somebody tell me? Is it positive skewed or it is negative skewed? Yes? Which skewness is this?
Positive skew.
Positive skewed. Is it positively skewed or negatively skewed? This is skewness to the left. And then we also have skewness to the right. When it is to the left, how do we call it? And when it's to the right, what's the name for that? Okay. So now that is over that. Let me take you to the data set. And then we are so much interested, not even before the data set. I need to go and tell you now the outlier. Outlier is supposed to be identified with the use of, we have already identified this as an outlier. Yeah, this is now the one that is used for identifying outlier. So in this case, we have outlier at data at 253, 167, 255, 94, 193, 183. So 253, 167, 255, 94, 193, 183. So how many outliers do we have here? 1, 2, 3, 4, 5, 6. There are 6 outliers in this particular data set. And it is not our responsibility only to identify outlier. After identifying outlier, we must be able to do what? Correct the outlier. So I take you back to the data set where we are going to do what? Where we are going to identify where these outliers are and then rectify them one by one. The first outlier is 94. So I will go to 94, data set number 94, and then I call it as an outlier. This data set is where the data set is, so that yes, 106, that is an outlier. So we said all these outliers were outliers to the upper zone, which means they are outliers, not smaller values, but higher values. So how do you treat that? Go back to that same data set, then delete it. So it will be missing. And then we shall apply the missing value system. And before I do that, please, I need to go back. Okay. So before I do that, let me create another variable called weight number 3. So I can copy this, copy all this. You can even do it like that. And then you create it here, you paste. Okay. Then give it a name, the weight underscore 3. Let's create weight underscore 3 so that we work with that weight. So this one, I will call it here now W weight underscore 3. Now, why am I creating weight underscore 3? It's because any operation that we perform, especially when it is geared towards changing anything, we must leave the original data set the way it was for future references. So you cannot alter any variable and change onto the original variable because you will lose the original data set. Why are we behaving like that? we are behaving like that to allow for, in case I make any error here, I can simply revisit weight underscore 2 and change that particular, make everything right. So that any operation you want to do transformation, it's normally important that you create a new variable that you want to work with. So that is exactly what I've already done here. So I will go to data set number 95 and eliminate that particular variable. It is this one. I will now eliminate it. I simply now delete it out. Then I go to I go next to 167, and then I also remove that outlier. 167, I remove outlier. Now I'm taking you through the procedure of eliminate outlier from your data set. So I go back to the next question, and then 120 is also an outlier. I remove it. Then after that, I come to 183. 183 is also outlier. I just need to reach 183, and once I'm at 183, I go like this, and then I delete it also. Then I go now to 193. I go now to 193. It's not an outlier. So I come here. This is 193. I just come there, and then I delete it again. Then 193, I've already done that. So 183, I've done 255 and 253. That I start with 253. I come with 253. That is another outlier. And 253 here is an outlier. 160. I remove it. Next is 255. 255 is another outlier. I bring here, I remove it also. Now I've already eliminated all outliers in this my data set. The only thing that is remaining now is to replace all the values that I've already eliminated. And now it's going back to what you call missing value treatment. So I come to transform, and then I replace missing values. Then instead of this, I now return this, and now I bring in weight number 3, the weight that I've just created. I bring it inside here. And then I will create now weight number 4, which does not have now an outlier. And then I change that. Then after that, I replace, being a continuous variable, I replace with mean of nearby points. Then I come here and say, okay. And then now I say, okay, I've already created a new variable. And I want to go and confirm whether my new variable has an outlier, So I now come back here. This is my data set. And then I do what? This is the data set I have. So I think all of you, 4 is the new weight that I've created. So I need to confirm whether in the process of doing data cleanup, I created more other outliers. So I come now, and then I do what? I now come and run descriptive statistics. I come to explore again, and then I bring in now that particular weight underscore 4, the final weight underscore 4, W underscore 4. So anyone who has already seen that W underscore 4, this is underscore 2, underscore 4. Is it this one? Yes. I can't say it is that one. Yes, it is that one. So in that case, I come to plots, equal histogram and normality. Then I come and say, okay, so that I can be able to generate new operations. So that new operations, I come and now share with you. I can come and share with you exactly what I've already generated here. So now, if you look at this, my graph, it looks a little bit better than the previous one. Now you can even look at it and see that at least it's a little bit better. Now, what about whether it has a normal distribution or not? That is what we want to test. This is 0.023. It is still lacking normal distribution, since this value is still less than 0.05. So that is exactly what we need now to do. And then now look at the box plots. We're so much interested in whether we have an outlier or not. Now, this particular data is very clean. We don't have an outlier. This extension is called whiskers. It's simply pointing where the outlier is. It can either be at the lower zone or upper zone. So if you look at the lower zone, it is clean, and the upper zone, it is clean. So it simply means our data set weight is now free from any aspect of extreme values. And therefore, we are free to proceed with that particular data set in our subsequent analysis that we shall be performing. If at all we are doing whether there is any correlation between weight and any other variables like height, this data has already qualified. since outlier will distort readings, and therefore we shall be making that there is a relationship in a case where we don't have a relationship, the so-called type 1 or type 2 errors. Okay, so now this is some of the operations that we are supposed to do. So now after that, I need to take you back to the same data set. Then now I draw in what you call whether the two data set I need now to bring in, I bring in even weight, and then I try to compare weight and height. And then after that, I do this manual kind of operation. So these are some of the basic things that we normally do before that analysis can already begin, which means wherever now I want to begin that analysis is from a data set that has already been cleaned. Both categorical variable and continuous variable are supposed to be cleaned so that at least now they can support data analysis. So thank you so much for being attentive to the class. Now, at least we are free now. Next time when we meet, we shall begin our analysis because we have already done what you call the basic steps. The basic step, which is data cleanup process. So I will stop recording.